Hi, I'm Deborah Kurata. I'm a software developer and Pluralsight author coming to you from sunny California. Today we're going to talk about Angular RxJS terms, tips, and patterns. Let's get started. And we're going to be talking about four key RxJS patterns: the declarative data access pattern, the retrieve on action pattern, shape on action pattern, and retrieve related data pattern. So those are the four we're going to concentrate on today. But we're going to start with some terms first to make sure that we are all on the same page regarding our RxJS/Angular terminology. So the first term, of course, with RxJS is observable. And what is an observable? It's basically a collection of items over time. But unlike an array, because array is also, of course, a different kind of collection, unlike an array, it doesn't retain those items. The emitted items can be observed over time. So say, for example, you're tracking key presses. You could put those into an array. So you have an A, P, P, and so on. If that was an observable, it would instead be like that, and that, and that. They're just kind of occurring over time. So if you said, okay, what's the third one? It would be, I don't know, I just gave you a bunch of them. I don't know what the third one was. So that's something really important to keep in mind as you're working with observables. You could kind of think of an observable like a drive-up window. The person at the window emits food items over time. And if you went back around and asked the person at the window, hey, what was in the bag of stuff you just gave me? They would go, I don't know, I just gave you the bag and it's up to you to deal with whatever's in there. Once I gave it to you, I have no recollection and you're gone. So you can kind of think of an observable like that. Why would you want to use an observable? Well, it's really great for things that arrive over time, like key presses, mouse movements, button clicks, and of course, our HTTP responses. Because as you recall, when you access HTTP, you issue a request with our HTTP GET, put, post, whatever. So you issue that request. It first has to find its way to the endpoint, and then once it's found its way off to that endpoint, then it executes some code. Maybe it calls the stored procedure on SQL Server, and it has to collect the data, and so it's all taking some amount of time. At some later point in time, that response is actually returned to you, and so it's a really good use of observables. You can also use it for notifications, process complete, process failure, and so on. Using an observable helps us very easily react to arrivals or emissions and those notifications. The other cool thing about observables, though, is they also work with synchronous data. So you can treat an array as an observable. You can treat any set of data as an observable. So it doesn't necessarily have to arrive on time, but that's really what it's good at. What does an observable do? Nothing. An observable does nothing until a consumer subscribes. When subscribed, the observable begins emitting items or notifications to the consumer, and it only does 3. There's only 3 of them that it does. Next, when the next item is emitted, and as part of that payload, then it gives you that next item. Error, when an error occurs, and once an error occurs, no more items are going to be emitted, and then complete, no more items are emitted. Going back to our metaphor, next is like the next car drives up and the person at the window hands them the next bag of food. An error, you can think of the cash register going down and they can't do any more transactions, so no more items are going to be emitted. And complete, it's the end of the day and they are shutting down and not taking any more orders. And those are the 3 notifications that you work with observables. All right, so along the way throughout this talk, you'll notice that I'm going to throw in some tips. And here's my first tip. Marble diagrams aid in visualizing an observable. Now, I take a very overly simplified view of marble diagrams. So if you've seen a real one, you know that this is quite simplified, but I think it does a good job of making the point. So in this case, the observable is the line with the arrow on it. The emission is that marble, that purple dot on there, and the straight vertical line is the complete. I have one and done there listed on the left because when you work with HTTP, your observable is one and done. It returns you the response from that HTTP request, and then it's done. That's it. You get that complete, and that's the end of it. But you also might have a more infinite observables. For example, that keyboard input, where it's just going to keep tracking what you're typing. One of the nice things about Angular is that it creates these observables for us. Routing emits parameters via a param-map observable. Form control emits a value via a value changes observable. And the one we've been talking about, HTTP client, emits the response via an observable. So here's some code. We've probably seen this kind of code a gazillion times. This is in the Angular documentation and pretty much all the sample apps. We have some kind of method like getProducts. It returns an observable that's going to emit an array of products. That's what that generic syntax is. And then it returns the response from the HTTP get. The generic parameter there is specifying that when it receives that response back from the backend server, that it should map it to an array of items matching your product interface. So that's what that generic parameter is telling you. In the component then, we go ahead and call that method. So question, what does this code do? It does absolutely nothing. So why does it do nothing? Because an observable does not do anything until a consumer subscribes. So that takes us to our next term, subscription. Like the ever-increasing number of streaming services, you have to have a subscription for it to emit anything for you. So if you want to watch that new Star Trek series, you have to get CBS All Access. If you want to watch Mandalorian, you've got to get Disney Plus. You've got to have that subscription before you can start downloading those or viewing those programs. And in RxJS land, it's similar. You have to subscribe before it's going to start giving you something. Technically speaking, a subscription is an object that represents the execution of an observable. So we add .subscribe on there. The subscribe returns that object, that subscription object, and we can sign it into a variable. Here's another tip. Ensure each observable is subscribed and ensure each subscription is unsubscribed. So here is our component in a more complete sense. So we've got the whole on init, on destroy. Our ng on init is calling our subscribe. So there's our subscribe. It's putting it into a variable so that we can then on the destroy unsubscribe. And that ensures that we don't have any memory leaks. Okay, so that's all fine and good. We're calling our method. We're getting back a subscription. Where's our data? How do we work with that emitted value? Where is our array of products? That's where that third term, our third and last term comes in. An observer watches for emissions and notifications. What notifications? Do you remember what they are? Next, error, complete. Okay, so our observer is going to watch for those three notifications. Now you can define an explicit observer, though this is uncommon. I just like to kind of show this because it makes it more clear what an observer is, though we don't normally write code like this. But an observer is an object with three methods. A next method defined with an arrow function. It receives that emission, which in this case is an apple, and it performs an operation, which is logging. The error receives the actual error. Again, the action is logging. The complete doesn't give you any payload, but it does allow for an action. You need to then pass that observer in to the subscribe in order for it to actually react to those. But as I said, this is uncommon. What do we do instead? We do our observer with an arrow function. So here's our subscribe, and directly in our subscribe is where we have our next function. So we receive our next item, which is an apple, and we log it. A couple of years ago, RxJS was changed such that subscribe will only take one argument. So it can either be that next function, or it can be an object with our observer. So our next error and complete. Now you don't have to have all three of them. Most Angular applications you'll only see next and error frequently. You won't see the complete because there's nothing special that needs to be done on complete for that particular case. Okay, so looking at our set of code then, our source dollar is an observable. We have a dollar on the end of that to identify that as an observable, so that we can tell that it's not an array or some other kind of data structure. The subscription is what we get when we call subscribe. Then we can use it to unsubscribe, and then we're passing in our observer with our next error and complete. All right, so those were our terms: observable, subscription, observer. Everyone's good? All right, there's one more thing that I want to cover before we jump into our patterns, and that is pipes. So when you work with RxJS, you can specify a pipe which transforms each emitted item. For example, say we emitted an A, we could pipe it through a lowercase operator and it becomes a lowercase a. We can pipe that same A through an enlarge operator, and then we have a bigger lowercase a. So that is kind of how piping works. It takes in the emitted value, it performs some operation on it, and then it emits to the next operator in the pipeline. Okay, so you can kind of think of this as a pipeline that's going to perform operations on your emitted items. Some common pipeable RxJS operators include tap, which taps into the stream without changing it. That's really great for debugging. I highly recommend, if you're having problems with RxJS, to start putting a bunch of taps in so you can see what's happening at each step. Map is a basic transformation. Catch error catches errors, and there's about 100 more that we're not going to all cover in this little time frame here, because I want to focus on these patterns that we're going to get to here in just a second. All right, so what does a pipe look like in our code? So we start the stream with a subscribe, then we pipe through a set of operators. So there's our tap, so we're just logging out what we are getting from our source, and then we're mapping. We're calling add to juicer to manipulate that apple into juice, and then we're subscribing. Then we're using the map to process each of the items. Notice that there's no need for an observer because we can process the items instead through these pipeable operators. You can still have an observer there if you also want to do something else, but you don't have to have one. And then, of course, we stop the stream when we're done with an unsubscribe. All right, so that's piping. Are we good? Okay, so now we're to patterns. Are we ready? All right, so I, like many of you probably, try to really support the community. So I try to participate on Stack Overflow such that I can. I try to help people on Twitter. There are discussion groups associated with my Pluralsight courses that I try to help people on. And one of the questions that I get frequently is, I don't even know where to start with this RxJS stuff. How do you even think about it? And I kind of realized that it actually, all of RxJS kind of works with this basic idea of three things. What do you have? What do you want? When do you want it? So if you think of all of your RxJS, what you need to do to make your RxJS pipelines work, answering these three questions, as simple and short that they are, they actually do help you think through your RxJS. So let's actually try these with our 4 patterns. So here's my sample application. I've got a list of products on the left. So there's each of the products. And this is my design. And what I need to do as a developer is I need to get my RxJS to produce this list so I can display it on my page. So how do I do that? What do I have? Well, starting up the app, I don't have anything. I have nothing. What do we want? We want the list of products. When do we want it? We want it on the initialization of the component. So here is our classic pattern for retrieving data, the code in our service. And we've already looked at code very similar to this. This one just has the piping tap to display some data to make sure that our HTTP GET worked and a catch error. And then in our component, we've already seen this code as well. The only part that's different is we are now taking the products we've received from that service and putting them into a component level property, our products property that we can then bind to. So this all looks familiar, yeah? But notice that our service was procedural, meaning that we're using a getProducts method in order to retrieve our data. What if we instead made it declarative? So instead of a subroutine that we're going to call, let's just declare a variable. So it's products dollar. Again, the dollar is because this variable now represents an observable. The rest of the code is basically everything from that return statement. So we're just now have a variable for our observable. Okay, our component then looked like this with our call to our procedural method there. If we went with a declarative approach, we could simply do something like that. Way less code. Wait, we don't have any subscribe or unsubscribe. How is that going to work? How are we going to make this go? We already said this doesn't work unless you subscribe or unsubscribe. We're going to use the async pipe. That's our next tip. Use the async pipe. Now, it's important not to get this pipe confused with our other kinds of pipe. We were just talking about RxJS pipelines and the .pipe keyword. This is a template kind of pipe, like our date pipe and our number pipe and all of those kinds of pipes. So it looks like this with that pipe character, that vertical, the vertical line that tells it to do async. So what we're doing is we're going to bind to our observable. So it's got the products dollar pipe async. And what the async will do is automatically subscribe for us and unsubscribe for us. So we don't have to have that in our code, yay. What the as does is anytime products dollar emits, it will emit into that variable so that we can then use it. So let product of products, we can then use that products variable that it emitted that array of products into. Are we good? Okay, so what we've just done is talk through the declarative data access pattern. So we have our products in our service, our products dollar also in our component that simply references the one in the service, and our async pipe in our template. And that is our first pattern. Okay, marble diagram, can't forget that. So here's my incredibly simplistic marble diagram. So I call this a data stream because it's actually retrieving data, and there is my array of data, and of course it completes because it's one and done. Moving on to our second pattern. So this is a different pattern that we're going to talk about next. In this case, we have now a drop down on our product list where you're going to pick a category. So we pick a category and then we only list the products for that category. Why would we want to do this? Well, maybe we have, millions of products like Amazon, or hundreds of products, way too many for the user to scroll through. And we want to give them some kind of way to break down that criteria and only get then those products matching that criteria. All right, so what are we going to do? How do we begin to attack this as developers? How are we going to do it? What do we have? Well, we have the category that the user is going to pick. We have that action that the user is going to do. What do we want? We want all of the products for that category. Okay, so What do we have? We have the action. What do we want? We want the list of products only for that category. When do we want it? Anytime the user performs that action, anytime they pick a new category. So our problem now is that we no longer have a method. And if we don't have a method, we have no way to pass in this category ID. So how are we going to get that data? How are we going to pass it in? So what is our alternative? I've said the word action several times here. Anytime you hear that yourself say, we have an action, or when do we want it? We want it when an action occurs. You want to think to yourself that we're going to follow a specific pattern that knows how to deal with actions. This brings us to our next tip. To respond to an action, use a subject or behavior subject. Now, a subject and behavior subject are special types of observables. So they're special kinds of observables that we create ourselves. So here's a subject. I'm using private to create the subject, and I'm using the new keyword to create a new instance of a subject. The generic argument there defines what I plan to emit into the subject I'm creating. So I want to pass in a number, that category ID. Now I want to make that private because I don't want any other code in the application other than this particular service to be able to emit things into that directly, or to be able to complete my stream, or to be able to arrow it out, or anyhow mess with my, my observable stream that I'm creating. Instead, that second line of code is exposing the read-only part, the observable part of that subject. And so that we are allowing to be public. And notice it has the $ suffix on it, identifying it as the observable. Okay, so that's a subject, and it's basically an observable that we're creating ourselves, that we're going to emit into ourselves. What's the difference between that and a behavior subject? A behavior subject allows us to have a default value. When you define a subject, it doesn't immediately emit anything until the stream, till we actually emit something into the stream. A behavior subject will initially emit a default value, which is in this case that 1 that you see in the constructor parameter. The other thing a behavior subject will do then is if someone subscribes late, they will get the most recent emitted value. So they will always get a value when they start off. When would you use a subject versus a behavior subject? Well, in our particular case, we don't want a default category. We want the user to pick a category. So we don't want a default, so we want to use a subject. If we always wanted to start with a general category or a on sale category or whatever, then we could define our behavior subject with that particular ID. The next thing I want to just bring up is how we emit the value. So we're going to use a subject and we're going to emit a value. Normally what we do is create a subroutine in the same service that we define the subject. We take in a parameter defining what it is that we want to emit into the stream, and then we call next. The subject has 3 methods on it. Next is 1. Anyone want to guess what the other 2 are? Error, that's correct, and complete, that's right. So it's very consistent with how this works. So we can next, we can error, we can complete. So here we're nexting in this category. So what we would do is when the user makes a change in the UI, the component would call selected category changed, passing in that category ID. Next would emit that into the stream, and then category selected action would emit it to anyone who has subscribed to that stream. Okay, so now let's go back to our pattern. So what did we say we had? We had our action. So now we've defined what we have with our subject. Somehow then we need to take that category ID and issue an HTTP request. So now we know that our category selected action is going to emit a category ID. So in that second line there where it says map, question, map, we get that category ID so we can use it in our inner observable. So notice that this is an observable inside our category selected action observable. So now we've got 2 levels of observable. So looking at this code, we have 2 problems. One, what kind of map should we use to make this actually work? And 2, if we use the async pipe and subscribe to our products dollar, that will automatically subscribe to our category selected action dollar. But what's going to subscribe to that inner observable? We have our inner observable, we have some kind of map we're supposed to use, and that brings us to our next tip, which is leverage your IDE. How is your IDE going to help with this? Well, if we decided to try mapping, because that's usually the first thing we want to try, is we want to try a map. So here's my code, here's a screenshot from VS Code, and I just tried a map there, and I have that same line of code. If you hover over products dollar in VS Code, it will show you kind of above that line that we have an observable of product array. And that's not what we want. We want an observable of product array. So that's one problem, that we have this wrapped value that isn't in the format that we're wanting it. And we also still have to deal with the fact that we've got that inner observable, which then leads us to our next tip. To subscribe to an inner observable and flatten the result, we want to use a higher order mapping operator, also called a flattening operator. These higher order mapping operators automatically subscribe to the inner observable. They then flatten the resulting observable, so you'll get observable of your type, not observable of your type, which would be not what you wanted. And it automatically unsubscribes from the inner observable, so you don't have to worry about that inner observable at all. Some common higher order mapping operators: switchMap stops the current operation and performs the new operation. concatMap performs each operation one at a time in order, and mergeMap performs each operation concurrently. And we're going to talk through an example of each of these in a minute to hopefully make more sense out of those if you're not already familiar with them. Okay, we are going back to our retrieve on action pattern. So what do we have again? We have our the user selected category. And now we have our code here with our pipe, and we're going to use a switch map. First of all, it will automatically subscribe to our inner observable, and then it will automatically flatten the result and automatically unsubscribe from it. If we hover over products dollar now in Visual Studio in VS Code, you would see that it is observable of product array, not observable of product array. So we'll get the right thing here. Here's my marble diagram. So on my action stream, so I call this an action stream because it's based on the user's action. The user clicked category 42. It runs through the switch map and it results in an array of products for that. If the user later says, no, I want category 15, it will again execute the switch map and provide you a list of products for that particular category. But the question is, why switch map? Why not concatMap or mergeMap? So let's talk through an example of why switch map makes sense here. Let's say that we have 3 categories, 1, 2, and 3, just to make the numbers easy to remember. The user picks 2, no 3, no 1. Okay, with a switch map, so it's going to go out to get category 2, sees that the user picked category 3, cancel that request, switch over to 3, issue that request, see that the user picked 1, cancel and switch over to the 1, and only return then the last one that they picked, which was category 1. If we use concatMap, what it would do if the user said 2, no 3, no 1, it would go get 2, wait for it to come back, then get 3, wait for it to come back, then get 1, and wait for it to come back. And depending upon your UI and the speed, it might be very confusing because the last thing they picked was 1 and they're getting 2, and a couple seconds later they'll see 3, and so on. mergeMap, on the other hand, will issue them all at once or right away. So it would, if the user picked 2, then 3, then 1, mergeMap will shoot off 2, then 3, then 1. And if 2 happens to be a huge set of products and take longer, even though 1 was the last one they picked, it could actually return the results of 2 last, and that's what you would get here. So then you're going to have this really strange bug where sometimes when the user picks a category right after another category, they're not seeing the right one. So that was my answer. Why not concatMap or mergeMap? All righty. So that was the end of that pattern. Our third pattern is the shape on action pattern. And so the idea here is that we're shaping the data. We aren't going to retrieve more data. So here we've got a list of products. When the user picks one, we want to display the detail. Now we could go back to the server and get it and follow the same pattern that we just looked at, retrieve on action. But in our case, our products don't change very often. Once the user downloads them, that set of them, we can just filter it to display the one. So that's what we're going to look at for this pattern. Okay, so our question again is, what do we have? Well, in this case, we have our list of products and we have an action. Okay, as soon as I'm saying action, we're thinking to ourselves, hey, we're going to probably need a subject or behavior subject. What do we want? We want the detail for the selected product. When do we want it? Anytime the product changes. Here's our products. This is the exact code that we looked at just a moment ago with our switchMap. So that's one of the things we have. The other thing that we have then is this action. So again, we're going to define a subject. Now we don't want to auto pick one of the products. So we don't want a behavior subject. We want a subject. So now we have 2 streams. We've got our product stream, which has all of our products, and our product selected action observable that emits the one that the user just picked. We need both of those to work together in order to find that ID that was emitted in that list of products. How are we going to do that? Well, whenever you need to work with multiple streams, the first thing that you probably want to think about is a combination operator. Combination operators, for example, are combineLatest, which emits a combined value when any of the observables emit, and they won't emit until all observables have emitted at least once. Now that sounds kind of complicated, but if you've ever in your code wanted your code to stop and wait to do the next step until it's retrieved the data back from the server, combineLatest might be what you want. There's also a merge, which emits the one value when any of the observables emit. Merge is most often used when you're dealing with like things. So not customers and orders, but current customers and past customers that you want to merge them into a list of customers. Last one is forkJoin, when all observables complete, and that's an important part of this, when all observables complete, emit the last value from each observable into an array. When we talk about action observables, and we're talking about them continuing because the user could continue to pick different categories or continue to do paging or whatever they're going to do, those observables aren't going to complete. So you don't want to fork join them because they'll never emit anything because it won't emit until all of the observables you're fork joining are complete. All right, so the shape on action pattern. So what did we have? We've got our products. We also have our product selected subject, this action of what product we've just picked, and we are going to merge them using combineLatest. So combineLatest takes an array. I only have 2 that I'm combining, but I could be combining any number of them. What they emit then is an array where the first element is the emitted value from the first stream. The second element is the emitted value from the second stream, and so on, however many streams that you define. By doing that, that then gives us access to our actual list of products and the actual product ID, so we could use it to find the one that we're looking for. So that's very useful for shaping or finding or filtering or anything like that that you might want to do. All right, so our marble diagram, our data stream is the data that we originally requested. Then the user says, hey, I want the detail for product 1, and we get the SAW. And then if the user picks, hey, I want the third product, and then it will return X. So our fourth and last pattern that we're going to cover here is the retrieve related data pattern. And we have two sort of subtypes here. Our first subtype is when there's a one-to-one relationship. So our product has one supplier and the product has an ID for that supplier, and we want to get the data related to that. So again, what do we have? We have our product, and the user selected that product. What do we want? We want the associated supplier. When do we want it? Anytime the user picks a different product, we want to get that product's supplier. As we said, we had the selected product. This was the code we just looked at. So this is defining that it's going to emit that one product that was selected by finding it in the observable with all the products in it. Then what we're going to do is pipe our selected product through switchMap so that it automatically subscribes to this inner observable and gets that associated supplier. So it's very similar. And again, we would use a switchMap here because the user could say, I want product 1, no 7, no 15, and it will just keep canceling the prior ones and get the last one the user picked. All right, but what about many? What if you had many suppliers that could provide this product, and then when you need to reorder, you could pick from that list of suppliers? How do you deal with that? Say in this case, our product has then an array of supplier IDs, and we want to somehow go through that array to get all of these suppliers. So here is an example that is not the best implementation of how to do this. And the reason I'm doing this first is because it's very explicit and easier to talk through. So here I have product suppliers, dollars. So that's my observable. That's going to be the array of product suppliers associated with a product. So here's that selected product. I'm going to pipe it through a switchMap just like I did before. But now instead of just using that ID, I'm going to use the array of IDs. So product.supplier IDs is an array. I'm going to use from, because what from does is it creates an observable from an array. Why do I want to create an observable from the array? Because I want to pipe it some more. I can't pipe an array. I need it to be an observable in order to have it emit the individual IDs and to be able to pipe those individual IDs through this pipeline. So inside my pipeline, I'm using a mergeMap to get this, take the supplier ID and then get the supplier. And I'm using a higher order mapping operator because again, I want to have it automatically subscribe to this inner observable and unsubscribe, and also to flatten it. Why mergeMap here? Well, let's envision that we had switchMap. So my product ID, supplier IDs, for example, just to be simple, let's say they're 1, 2, and 3. If I had switchMap, it would go to get 1, cancel it, get 2, cancel it, get 3, and I'd only end up with 3. When what I want is all of them. So you would never want to use switchMap in that particular case. I could use concatMap, and what that would do is get 1, wait for it to come back, then get 2, wait for it to come back, then get 3, which if you need them in order might be what you want to do. mergeMap will go, okay, I need 1, 2, 3, it'll send all those out and it'll just collect them as they come back, not concerned about order. The last thing then we do is a to array, and what that to array will do is ensure that each of these individual return suppliers are added to an array. Otherwise, our product suppliers will emit 1 at a time, and our UI will show 1 and then it'll disappear, and then it'll show the next one, it'll disappear, and we want it to show the array of them. So I said this is not the best implementation. What do you really want to do? Well, let's take this whole piece here and replace it with one operator. Anybody want to guess what it is? It is forkJoin. So what we can do instead is a forkJoin, and a forkJoin basically does what all that other stuff did, only it does it with one creation function, forkJoin. So what this is doing is it's taking our supplier IDs, it's mapping them all, it's automatically subscribing to our inner observables, and it's joining those all together into an array for us. And it still then results in product suppliers dollar being an array of product suppliers. Okay, in a marble diagram, there's our product stream. So we had a saw that the user picked, and it's going to, in this case, there were only two suppliers. It's going to forkJoin them, and then it's going to give those to us. And if the user then picked another one, it would then have more data streams and put them together and emit it. So what patterns did we cover? We covered the declarative data access pattern. And one of the benefits of that pattern is that it makes it a whole lot easier to use any of these other patterns. And you can use that anytime you want to retrieve simple data. Then we've got a retrieve on action pattern. And this is good for retrieving based on a user selection. So we could have used that if we actually wanted to go to the server every time the user picked a new product. We can use it for user selection of a category and only want to get products for a category. You can use it for paging. I only want the first page of data. Now I want the second page of data. So you can use the same pattern, that exact same set of pipeline operators for paging. The shape on action pattern we can use for filtering, mapping, or transforming an observable on user selection. So that's making the assumption that you're not going out to get new data, but rather you're going to somehow modify the data that you have, filtering or transforming it in some way. And then the last one was retrieve related data pattern. One of the most common uses for that one is to deal with users. So the user logs in, you get the user ID, then you take that ID to get the related data, their posts or their customers or their orders or whatever having to do with that user. And it can be one, in that case, it would be one user ID getting all the data for that. Or in our example, we had multiple IDs. All right, so here are some links. I did an example called Angular-action streams, which shows how to do some of these action streams. How many of you are familiar with Tour of Heroes? Does anybody work through that, the Tour of Heroes? So what I did is I took the Tour of Heroes from the Angular documentation and I converted the whole thing to be a completely declarative approach using some of these patterns. So if you're familiar with Tour of Heroes and you want to see what it would look like in a declarative way, that's that. Hope this information will help you on your next Angular project. If you have any questions, reach out to me on Twitter. Thanks for joining me.